Okay, so if you have been given a go at these questions, I'm going to pop the answers up. Don't worry too much if you're rusty on your SERDS work or if you didn't actually cover it, because obviously this year you have not necessarily covered everything that we would have in an ideal year. So don't worry too much. If it is something you're thinking that's really easy, we do work through some more challenging stuff through A level as well. So your answers should be on the screen. Okay, so we'll come back through to these if you've got any questions. If you haven't done them, there's no need to worry. As we go through, as I said, we'll come back onto the actual maths work once I've done the introduction to what the course is, what it looks like, and all of those sorts of important parts in a moment. So, what is A-level maths at the Wren School? And I was talking to my year 12s currently. We have a group of year 12s who are currently sitting their exams, and so what they would want to know and what sort of things they would ask, also from the year 11s that were at the Wren last year or this year, of what they have been asking. So what do we study? Now, when we study A-level maths at any point, so in any school, in any college, anywhere else, you will study the same course, you'll study the same topics. We are following the AQA specification, but the main difference between those is the exams and what they look like. The actual content of the A-level is the same compared to EdXL, OCR, and anything in between. So what we are studying is what we will study is our pure topics. So our pure topics are our numerical methods, our SERDS work. We do loads of algebra work, lots of really interesting stuff there. We go into calculus, so integration and differentiation. I'll show you a list of topics in a moment. We then also study statistics topics, including a large data set. This year it's on transport and looking at a large data collection on transport. And then we also study mechanics topics. That's more in that sort of physics style, looking at forces and things similar. I'll show you a list in a moment. A typical lesson would look like probably quite standard to what you know. We often go through recap work and then examples, modelled work, depending on the topic. Some of these take longer than others. And then it's practice work, practice topics, practice questions, sharing of ideas. It depends on the class size of how much we'll sort of look at group work, but we are looking at quite typical to GCSE, sort of that bridge between GCSE and university. There is quite a lot of instruction from us at the front, but we do sort of encourage group work as we go through. Just letting somebody in. Okay, no, not. So. Oh, sorry. So typical lesson, we talked about how much work am I expected to do? Now, expectations of work at A-level, obviously people are going to talk to you about that, is roughly about 1 hour's worth of independent work for every hour lesson that you have. In maths, we definitely follow that, if not a little bit more, mainly because when it comes to maths, the more practice you do, the better off you are. So the reality of that is that we need to encourage you to be doing that work, doing that practice. And you know that from GCSE maths, but hopefully you're doing a maths A-level because you enjoy it. So the practice should be, not completely a torturous thing. It should be something you're actually enjoying doing, and the process, getting the right answers, repeating it and seeing how you could apply new methods. Obviously we'll support you with that, and workload is a new transition for a lot of people. So when we're looking at workload, it is a transition into sixth form, but we will support you with it. Now, is it hard? Is the A-level hard? Yes, the A-level maths is hard. A-levels are hard in general. They should be. They should be a step up from GCSE. The gap between GCSE and A-level maths, if bridged properly, which is our aim here, as well as our aim, sorry, I'm just letting people in, which is our aim here, as well as our aim for, sorry, there we go. So if we bridge it properly, which is our aim now over the summer and in September, we'll be doing bridging topics, making sure we're very comfortable with the key top grade topics at GCSE. So we're doing that work, but it is difficult. It is a difficult course. There's some difficult concepts. And some students find they sort of hit that wall at some point in year 12 and think, oh, hang on a minute, maths used to come quite naturally and now it doesn't. You will get past that and then it will start to feel natural again. So it is, you should be doing maths because you enjoy it. If you enjoy it, you will absolutely make it through this course and we will have, a successful year. You won't enjoy every moment, which is absolutely fine. What do the exams look like? So the exams look like in 3 different papers. I'm going to show you the breakdown in just a moment about that. So I should probably put a question last, but that is what we're going to talk about in a moment. And then resources and materials I'll also be covering in just a moment to show you what we need. There isn't too much. I don't know what other subjects you're intending to do, but when it comes to maths, there isn't a huge amount of resources that you need as we work our way through. I will try and keep an eye on that chat. I know some people have come in late, so apologies if you're not sure, and do let me know if anything's coming up, can't hear me or anything changes, do put a note in the chat. So, resources. We will provide you with the course textbook. Now this year we actually bought physical copies of the textbook and they are huge. And we found that students didn't wish to carry them around, and that's quite a lot. So we'll probably do this via Caboodle, be a digital copy of the textbook. And of course at the Wren, we will be supplying laptops so you can access that. So we'll be doing that, you don't need to worry about the textbooks. Now when it comes to calculators, we will support you with getting the right calculator. However, if you wish to do that in advance, then I've given the model there. Is a Casio class with FX991EX. It looks just like the one you can see here. These are approximately £20 to £25, depending on where you buy them from. And you can absolutely buy your own. You do need this model or something more advanced. This is absolutely fine to do all the stuff we have. Your model from GCSE, obviously depending what you've got, is unlikely to be appropriate for the A level because you need to be able to do statistics functions and things like that. So just being aware of that calculator. If you haven't got one in September, we will probably order bulk and then either sell them through or loan them, etc. So don't worry about it. We will support you with getting one. But just if you wanted to get ahead of it, or you are preparing yourself for September and you want to buy your own version, please do buy this model because this is the model we will be working through. And then the course and assessment overview. You can see here, you have 3 papers at the end of year 13, so it's cumulative at the end. And paper 1 is all pure topics. You can see our list of pure topics there. You've got proof, algebra and functions, coordinate geometry, sequences, trigonometry, exponentials and logs, differentiation, integration and numerical methods. So there's a few new terms there, but also some terms that we've taken from GCSE and then take them up. This will be a 2-hour exam. And it's worth a third of your A level. They're all equally weighted. Paper 2 is any content from paper 1, so all the topics I just read to you, so all the pure topics will also or could also come up, plus the mechanics topics. So you can see there we study vectors, quantities, kinematics, forces and moments. Some of this in year 12, some of this in year 13. You can see the same assessment, 2 hours, 100 marks, etc. And then the last paper is also 2 hours. And any content from paper 1 once again. So that pure content is going through as a thread from paper 1 to 2 to 3. And then these ones are our statistics topics. We've got statistical sampling, presentation and interpretation, probability, distributions, and hypothesis testing. Again, we start these in year 12 and then pick them back up again in year 13 as we work through. So all of the topics that I've mentioned, including the pure, which I'll pop back to because that's probably where we're most aiming for, we will start off and then continue through. So that's very much the aim of our course, is that we begin something and then we build upon it. So we'll take what you need from GCSE, build you up to the AS standard for year 12, then take what you should know for AS and build up from there. Apologies if you can hear noise in the background. It is the road behind me. So moving on from the overview, then looking at SERDs and topics from there. I am just going to give me 30 seconds. Well, actually, I'll set some questions and then I will look. So, bridging topic of SERDs. Now, first question is, what is a SERD? Thinking about what you would know, I've already shown you some of that information, but can you define it is what's important. I'm just going to shut those windows. I'm going to pop that up for you to have a little read through whilst I do that for us. Sorry about that, guys. I just wouldn't want to carry on with that. So Looking at a surd, you probably have seen them, you probably know what they are, and depending on your experience at GCSE, you will have more or less knowledge on them. You would have used them. Some of the stuff we go to today, as I've said, I refer to it as a bridging topic because it is a topic you start at GCSE. It's that back end grade 7+ topic, and then we continue it into A level. Now, you can see that surds are used to write irrational numbers. A number is irrational if they cannot be written as a fraction. And surds are represented using that square root symbol. It could be a cube root or other root. We tend to stay on that square root, even through to A level as we work through. Now, why I'm looking at this is what I'm going to do is I'm going to work through some examples with you. So hopefully you've got a pen and paper, as I said at the beginning. We'll work through a couple of examples, and at the end of this session, I'll set you a bit of work. We next meet on Friday, and you'll be able to sort of mark through your work, see how you are with it. Now, as I've said, there are a number of people I don't know, and so I don't know your prior knowledge with surds. You may be very, very confident and think this is really easy. You may have never seen them. It might have been a topic that your school left out during the pandemic and the time we've been off. So, bear with, you're all going to come from different places. Either's fine. We can extend you through when you join us, or we can support you with that catch up. So neither of those is worrying to me, but just, I am aware that you're in different places with it. So please don't assume or worry that I'm assuming you're all either very confident or not confident at all. So as we work through, I'm going to attempt to write on these, and we will work through from there. So writing these numbers, so these numbers are surds, already in surd form, but we're looking for the simplest possible form. So we are simplifying our surds. So it'll be a good thing to write these down as I work through them, but of course you can go back onto this as I am recording as well. So if we're looking at root 12, I have got these questions also already written out on the next slide. So if my writing goes horribly wrong, so root 12 we would split up into two roots. Now I'm going to choose root 4, root 3. Now the reason I choose root 4, root 3 is because I'm looking for perfect squares. Perfect squares being numbers that when you square root them, they give you an integer answer. And I know that 4 times 3 makes 12. 6 times 2 isn't going to give me much help because neither 6 nor 2 are a square number. So then if I did root 4, root 3, root 4 is 2. So that simplifies us to root 3. Hopefully, if you have covered surds, this is something that you have covered within it. So if we're looking at the next set, okay, we've got root 72. And so I'm going to split root 72 up into two roots. We're going to think about square numbers that go into 72. Well, I know that 36 times 2 is 72, and so they are the ones that I am choosing. Now, you also might be thinking, well, I know that root 36 could be positive 6 or negative 6. We are focusing on our positive roots at this moment, okay? So I recognise that is clearly the case, but that is not what we are focusing on when we are simplifying these surds. We're focusing on the positive root. So root 36 is 6, and therefore that is 6 root 2 as a simplified surd. And you can't simplify this any further. And then looking at the last one, we've got root 150, and I'm going to simplify that into two surds. And so looking at those, I'm thinking, what square numbers do I know? I've got 1, 4, 9, 16, and I'm thinking 25. So we've got 25, moving up from there, wouldn't be any bigger ones. And so I'm going to have root 25, badly written there. I'm going to have root 25 and root 6. 6 times 25 makes 150. Root 25 is 5, and so therefore this is 5 root 6. Now, although 6 is not a prime, you'll notice 2 and 3 are. Although 6 is not a prime, you can still, you cannot take out a prime number from it or a square number from it. So we cannot simplify root 6 anymore in this method. Okay, so that's why it would remain as it is. Again, if there's any questions or you no longer can hear me or see me, I'll see the work, please also do tell me during the chat. So looking through from there, as I said before, we're looking for factors that are perfect squares. So if it doesn't work, try another one. Okay, a little bit of trial and error is never a bad thing, even when it comes to A-level maths. So this is our example 1. This is the first thing, one of the things that will come up in the task that we are looking at. It is also one of the first topics we look at A-level, depending on how many of you are attending now. We obviously can skip through this a little bit faster in September. So you can see full solutions are there, a bit neater writing than mine, if you did want to go back over them. So we're looking at adding and subtracting surds now. So I'm working us through that whole surds topic that at GCSE, you probably work through it in a week, 2 weeks. We're doing this in, what, 20 odd minutes as this section. So we are working through fairly quickly. I'll keep an eye on the time in case I work through not quick enough. So this one we are looking at adding and subtracting, and you can see a lot of blurb there. If I skip ahead, I've sort of taken out that key term. So we are looking for common surds in order to collect like terms. So when you're working on algebraic things and you have 3x plus 2x minus 4x, you're collecting like terms. That's exactly what we are doing here. We treat surds quite algebraically in a lot of ways, even though it is a numerical topic. I'm aware of the noise starting up behind me, but there's not much I can do about it. So if we look at these, we've got two integers, and we're going to put those together first. So I'm going to just rewrite this as 2 plus 3. So although we're in brackets, there's nothing multiplying in the front, so we've got nothing to expand out. So I'm taking my 2 plus 3, and then I've got plus root 2 minus 2 root 2. Would check maybe for a negative sign, as you can see coming up later, but at this moment, that's exactly the thing we're looking at. And then we've got 2 plus 3 is 5, plus root 2, subtract 2 lots of root 2. So that means I've got negative root 2 left, negative 1 root 2, okay, minus 1 root 2. However you want to see it or think about it, it's like having positive x plus x, take away 2x. We end up with minus 1x. So it's the same principle here. If we look at this next question, and that's as simple as we can get it. We can't put these together. Root 2 and 5 do not collect together. If we look at the next thing, the next question, we've got 4, and then we're subtracting 1, because that's minus 1 times 1. These are surds, these are surds, these are surds, so there are only integer values. And then I'm going to look at, I've got minus root 3 here. I'm going to put it with my other root 3 term, this one here, but remember it's going to be negative root 3 root 3. So negative 3 root 3, because that minus sign would multiply out here. And so I've looked at the 4 term, the 1, the root 3, and the minus root 3. And then here I have root 2. So it's going to be plus minus times a minus 2 root 2. So as we're working through this one, we're collecting up our like terms. So 4 take away 1 is 3. And then we have minus root 3, subtract 3 more root 3s. So that's minus 4 root 3. And lastly, we just got that plus root 2 at the end. Sorry, plus 2 root 2 at the end, which has nothing else to collect with. There's no other root 2 terms. Now we cannot simplify this any further, okay, because we've got an integer term, a constant term. Then we have got root 3s and we've got root 2s, and they cannot combine. So that is our final answer on this example here. Now when it comes to the last one, we're looking for those common surds that we talked about. So this one at this moment doesn't have anything common about it, and we can't combine 32 and 18. So what we need to do is need to think about if we can simplify them and therefore find common surds within it. So if I'm thinking about root 32, I'm just going to split this question off. How would I simplify using the methods from the previous slide, 32? Well, I'm thinking 4 goes in, so 4 as a square number would go in, and that would work. However, actually 16 goes in, and that's a bigger square number. If you know that 4 is a factor, try and check 16 usually is my suggestion. And so that'd be root 16, root 2. Now from there, we would simplify root 16, which is 4, root 2. So I know that root 32 is the same as 4 root 2. Let's have a look at root 18. So if we look at root 18, that, I'm thinking my square numbers, 1, 4, 9. So 9 times 2 makes 18. And therefore that is the same as 3, root 2. So now I have, if I rewrote this question, this is the same as 4 root 2, subtract 3 root 2. So 4 root 2 subtract 3 root 2 is going to be awfully written up here, apologies, but it's going to be 1 root 2 left. So your final answer would just be root 2. If you have the 1 in front of it, it's not going to be incorrect, same as you could write 1x instead of just x, but it's being aware of keeping it as simple as you possibly can. Again, I am keeping an eye on the chat, so at any point it goes wrong, you don't understand it, please do let me know, because I'm aware that I am just working through some questions. Again, you've got those solutions here if you want to look back to this as you work through. So if we're looking at our next topics, we've looked at simplifying, we've looked at adding and subtracting, now we're looking at multiplying. So this actually is easier in a lot of ways, okay? So it's just thinking about methods that we can use as we work our way through. So I've got root 2 times root 16. Reversing the simplifying method we did before, we can therefore write this as root 12. Because remember, we can just split it into our factors. We can write this as root 12. However, I'm probably not going to leave it as root 12, because thinking about, if I just said to you, simplify root 12, you would be thinking about, if I just said to you, simplify root 12, you would be thinking about what square numbers go into it. So let's cut down root 12 into root 4, root 3. Remember, we focus on those positive roots, and so that's going to be 2 root 3. So in fact, root 2 root 6 can be written as 2 root 3. Now, there's another way of thinking about this question. I swap colours. There's another way of thinking about this question is you could think about root 2 times root 6 as being root 2 times root 2 times root 3. Because that's root 6 there, isn't it? Here is root 6. So if you have root 2 times root 2, hopefully you know that root 2 times root 2 is 2. A root times a root gives us that whole number at the end. Okay, because if you think about that's going to be root 4, which is 2. Okay, so if you times square root, you times a third by itself, so root 2 times root 2, you end up with just the constant term, the integer term, as your answer. And you can see therefore it will be 2 root 3, which is the same answer we have up here. Okay, again, I recognise I'm doing this very fast for some. So do bear with me, you'll have the opportunity to rewatch. Again, we will go through this in person in September. However, it means that we can go through it a little bit quicker. So look at this next set here. Now, I can't really put these together. I could times everything out. But we're not with some quite big numbers to then look for the square root. So let's think about it. Can we actually cut this down to make our lives a little easier? So we've got 2 root 15 here. So I'm thinking, well, if I wrote that as 2 times root 3 times root 5. Okay, so that's my first term. So I'm going to put a bracket around it because it's just this term here. And if I multiply that by root 6, that's going to be the same as root 2 times root 3. Again, I'm going to put a bracket around it just to signify that that's just one term on its own. And then lastly, that's times 3 times root 10. Well, let's think about what we can split root 10 into. We can split root 10 into root 2, root 5. And now if we look at this question, you should be able to see that we've got multiple common sets. Okay, so looking through these, you can see, oh, lost the pen there, change it to colour I can't see. Okay, so you should be able to see that we've got multiple that go together. I'm going to switch back into the red. So if I rewrote this, I could write it out in my number form. You don't have to do it in all these stages. You could have skipped some stages, but let's write out our constants. So 2 root 3. I'm going to cross them off, knowing I've written them out, just so we get ourselves in a bit of an easier state. And then I've got root 2 times root 2. So they can go. I then have root 3. My writing's getting worse, apologies guys. Times root 3. So they can go. And then I have root 5 times root 5, which would be those 2 terms there. So if I put all this together, without a calculator, don't make yourselves, don't worry about making your lives any harder and try and do this all at once. That's 6. We then have root 2 times root 2, so that's times 2, using that method we used up here. Then we have root 3 times root 3, so that's times 3. And then we have root 5 times root 5, so that's times 5. And then working our way through that, 6 times 2 is 12, times 3, 36, times 5, 118. That would be our final answer there. Okay, So again, these methods are not independent. So we've used simplifying terms, we've used the same sort of methods working through. And that's a very common thread through A-level, is that at GCSE, you very much learn this is the topic, this is the topic, and this is another topic. And only when you look at some problem solving do you bring it through. When it comes to A-level, it is much more that it threads through a topic as you work through. So as we're working through those final bits of this, could have put that up earlier, but thinking about splitting surds to make it easier. And that's what we've been looking through in that topic there. So the second part of multiplying, we've got two more little bits to look at. But the second part of multiplying is actually multiplying out and expanding brackets. Now, this is a very common bit of GCSE to have focused on. So you probably, if you studied surds, you probably have looked at this. Now, we use the FOIL method, okay? So first, outer, inner, last, or whatever method you've looked at. But we just multiply bit by bit. So 2 times 1 is 2. 2 times negative 2/3 is minus 4. Sorry, not 2/3. Negative 2 root 3 is going to be 4 root 3. Root 3 times 1 is positive root 3. And root 3 times 2, or minus 2 root 3. Be careful, I'm going to write this out. Minus 2 root 3 root 3. What do I know about root 3 times root 3? That is 3. So this term here is 2 times 3, which is 6. Again, that might be quite challenging for some of you if you've not spent, if this is your first view of surds. We're doing quite a lot in one go. So I've therefore got 2 minus root 3 plus root 3, so minus 3 root 3. Oh, sorry. And minus 6. 2 take away 6, okay, it should be negative 4. So we're going to have minus 4 or negative 4 minus 3 root 3. A reminder that we can't put those together. Okay, so we have negative 4 minus 3 root 3. A little bit messy, as in not my writing, but as in the actual answer. But that's okay. Not everything in maths is going to fall out into a lovely sort of display. Now this one here, a trap that my A-levelers and GCSE guys, but fall through quite regularly, is just squaring the 2 terms inside this. You will have been reminded by your GCSE teacher, when this is squared, it means the whole thing is squared. Okay, so that means we're going to square everything times one bracket by the other. So 3 times 3 is 9. 3 times root 2 is minus 3 root 2. Minus root 2 times 3 is minus 3 root 2 once again. And then minus root 2 times minus root 2 is positive, negative times negative. Root 2 times root 2 is 2. Putting these together, 9 plus 2 is 11. And then we have got minus 3 root 2 minus 3 root 2, which is minus 6 root 2. Now I'm actually going to skip the last question because I'm aware of time. So looking at that last question, you'll be able to see the answers on the next slide. Again, I'm keeping an eye on your chat. So if anything, you do have any questions or want to ask anything, please do let me know. So you can see the answer to the last one is there. It's no different in terms of method. So I am just working my way through so that I can give you the work that I want to be working from. So the last section we're going to look at together in this is rationalising the denominator. Now this is essentially our version of division. Now something that's really important is in A-level maths you will not leave an answer with a surd at the bottom of the fraction or as the denominator. Okay, so often the question won't ask you to rationalise, it will be expected that you do. So looking at that, I'm going to just rewrite this one because it's too far over for me. So I am expecting to rationalise the denominator of 1 over root 3. What that means is you don't want a surd on the bottom. So how do you take the surd away from the denominator without changing the value of your term? So what you do is you multiply it by 1. But what I mean by multiplying by 1 is we multiply it by root 3 over root 3. Now, hopefully you will agree that root 3 over root 3, this blue fraction here, is 1. 2 over 2, 6 over 6, x over x. They all just equal 1. So multiplying by root 3 over root 3 does not change the value at all of my fraction, okay, because it is just being multiplied by 1. However, it does change how it looks. So that means I've now got 1 times root 3, which is root 3. And on the bottom, I've got root 3 times root 3, which we now know is 3. A reminder again that we have used the rule once again as a thread throughout this topic. So root 3 times root 3 is 3. So this is rationalised. There's nothing else we can do to this. We've got a denominator without a surd in it. You have done your job. So when it's just a term on its own, you just multiply by that term, top and bottom. If we look at the next example, this one's a little bit trickier. And we need to work it out in the same way, but we've got a different term. And you will see that there's some information at the top here, and we then multiply it by the same terms. However, we change the sign. I'm going to rewrite it again so I can write next to it. So we've got 1 over root 2 take away 1. And we're going to multiply that by root 2 plus 1 over root 2 plus 1. Okay, and it's important that you do change the sign. Otherwise, you just end up with a mess on the bottom and you don't get rid of those surds. Okay, so the reason that we do this means that our surds in the middle cancel out. I will show you what I mean. I'm going to rewrite this. So that means that we are working through on the top of our fraction. We've got root 2 plus 1 because we've got 1 times. And on the denominator, we've got root 2 minus 1, root 2 plus 1. Should have left myself slightly more space there. But this means that root 2 plus 1, I'm not going to change on the top. And then we expand this out. We've got root 2 times root 2, which is 2. We have root 2 times 1, which is plus root 2, minus 1 times root 2, which is minus root 2, and minus 1 times 1, which is minus 1. And then you'll see this plus root 2 and this minus root 2 cancel each other out, which is exactly what we're aiming for. So now we just have root 2 plus 1. Apologies for my running out of space here. Over 2 take away 1. Well, 2 take away 1 is 1. So that leaves me with my final answer, which I hope you can see, is root 2 plus 1. Okay, and it might end up with being, you might have a denominator on the bottom, but it should be numerical. Okay. Now the last example I'm going to go through is this one here. Same method. We're going to multiply it by the inverse, or not the inverse, but the inverse sign of the denominator. So we're going to multiply it by 1 plus root 3, 1 plus root 3, which therefore gives us on the top, we will have 2 plus root 3 times 1 plus root 3. Oh. And worse as I go through, apologies. And then we've got minus 1 minus root 3 times 1 plus root 3. And then we're just using that expanding that we did in the last set of examples. So again, that pulling thread all the way through to expand it out. So on the top, I've got 2 plus 2 root 3 plus root 3 plus 3. Root 3 times 3 is just 3. Over 1 plus root 3 minus root 3, which is what we expect, minus 3. Remember, root 3 times root 3 is 3. Negative times positive is a negative. We expect them to cancel out. Does not matter that the top doesn't. So our final answer is 2 plus 3, which is 5. 2 root 3 plus root 3 is 3 root 3. Over 1 take away 3, which is minus 2. Now, that's quite ugly in terms of maths and what it looks like, not just in terms of my writing, but this is the same as same as timesing by a half, okay, because it's over 2. So you could rewrite it alternatively as minus a half lots of 5 plus root 3. However, unless it asks you to put it in this form, or full bracket, unless it asks you to put it in that form, this is correct, nothing wrong with it, it's just ugly. in terms of maths. We talk about maths looking prettier and giving you answers in a pretty way, but it's absolutely not compulsory that you do. Now, I've gone through a number of examples there, very chalk and talk. That isn't always how it's going to be. I would obviously interact with you much more in a classroom setting than what we are in now. If there are any questions or any concerns, please do tell me. But hopefully those examples have made sense to you. Now, as I work through, that is the solutions there in a much easier way to work through if you're reading back and having a look through. We have then focused on simplifying and all of those from there. So your task, okay, your practice task I'll show you on the next slide in a moment, and then I will pop my camera back on and talk to you if there's any issues or any questions. The practice tasks I'm going to share with you in our sharing in just a moment. And please look at them, please try and complete them, please give them a go, okay? Obviously, there's not real any way that I'm going to be checking on those, but it is expected that you give them a go because it will give you that taster as you're working through. Now, the next session, I'll be going through the solutions to these questions that I've set you, and I'll be setting those summer bridging materials. Okay, we've worked on a booklet which gives you all the topics that we'll be working through. I'll talk about those on Friday's session. So our next lesson for us is on Friday, the 2nd of July, which is this Friday, at the same time as this lesson was at 11:40. Now, if there's any questions on the task or the course that you're not asking today and you want to ask later on, my email address is there. So please do get in touch. Now, the questions are here. I'm about to stop sharing my screen in a moment because then I can share this document with you as we work through. So don't take anything down. I'm going to attempt to share this with you in a moment. I do say the word attempt. We will give it a go in just a moment as we work through. So these are the questions I'm asking you to do. You can see they're all the sorts of questions we've just been doing. It'll just give you an idea about your practice and how you are getting on. So I am going to stop the recording there and stop sharing.